Okay, so I'm not going to do all the problems, but I'll just do a couple of each, just so that you get an example, because this is your second review sheet. So let me take this one over here. Now we can pretend there's a 1 there, right? So we can write a 1 here. So it's a -1 times a negative, so you get everything is going to turn out positive because you're multiplying by, not positive, but come out the opposite, right? So that's come out as positive 7 minus 12p plus 3k. And again, you can pretend there's a 1 here and do the distributive property. So plus 19k and plus 2p. There are like terms. The 7h actually was no 1, but p's and the k, so 7h I can combine, and I'm going to combine this guy with this guy. And if you think about it, it's negative 12p plus 2p is negative 10p. And the two k's can be combined. A positive and a positive is going to be another positive, and that's going to be 22k. I'll do this one at the bottom. So it's a negative times a negative is a positive. 5 times 4 is 20, and b times b to the second power is b cubed. Negative and negative is a positive again. 5 times 12 is 60, and bc, remember, you multiply the b and c, it's just bc, and then again positive 15a4b, remember, you should always be alphabetically, and then minus 5a cubed minus 11c, which is not going to be, the distributive probably does not apply to those two terms. Do I have anything in common? No, there's no like terms. Everything is different, so that's your final answer. Over here, I'm going to pick 2, and let's just pick, doesn't matter, let me pick this one. So it's 3/5 times 15, so let's just do one of them. So if you think about 3/5 times 15, right? I can multiply 3 times 15 and then divide it by 5, or I can divide by 5 and then multiply by 3. It doesn't really matter. So if I divide by 5, divide by 5 is 1, divide by 5 is going to be 3. Sorry, divided by, 3, and 3 times 3 is 9. So 3/5 times 15 is going to be, first of all, negative, and then 9k. And then you're going to do the same thing. 3/5 times 5, these two will cancel out, right? And you could just get 3h plus 3h. And lastly, it's a positive times a negative. You get a negative. And if you do this on the side, 3/5 times 70. So think about that. You can simplify the 5 and the 70. And that's going to give you 14. And 3 times 14 is 42. Likewise, the same thing. Coefficients with coefficients and variables with variables. So do these two, then these, then this, this. So you can apply the distributive property 4 times. Negative and a positive is a negative. 3 times 6 is 18. x5 with x is x to the 6. And don't forget the y. Negative and negative is positive again. 3 times 2 is 6. x5 with x is x to the 6. And y gives you y squared. Then move on. Again, positive. 3 times 5 is 15. The x5 multiplied with no 1. And the y5 is y6. Minus 3 times 9, or 3 times 9, 3 times negative 9 is positive 27. And the variables have to come. There's no variables here, but you still just keep it right next to the fifth y. Next section. I'm going to pull out the GCF. So again, the trick here is you can pull out something common. So I'm going to do this one and this one. So what's in common between 16, 8, and 64? The biggest number in common is the 8, right? And what's in common? Do they all share an A? Yes, they all share an A, so I can pull out an A. But I'm going to pull out the A with the lowest exponent, so it's going to be A to the second. And they all share a B, so I can pull out a B too, and the B with the smallest exponent is this one, B to the first. So now I'm going to find out what the terms inside. So think about this as this, right? So I need to find 3 terms. Oops. Make it bigger. It's going to be a term, subtract, another term, subtract, another term. So 8 times what? 16 times 2. And A second is A second, so I don't need to write the A's. And B times what would give me B to the 5th would be B to the 4th. So if you want to check right away, you can multiply these two right now. 8 times 8 is 16. A second multiplies with no 1, so I write it down. And B times B4 gives me B to the 5th power. So I get exactly what's out here. Next one. 8 divided by 8 is 1, right? And then the a second times what a over here will give you a to the fourth would be a to the second. And I have a b, so I can't write a b here because that's already in there. So it'd be, and then if you multiply this times this, you'll notice that you'll get this guy right here. 8 times 1 is 8. A to the second times a to the second is a to the fourth. And b times no b here is just b. That's exactly what we want. Last one. It's 64 divided by 8 is 8. A7, A2. So what kind of A can I put in here to give me an A7? Well, that's A2. This has to be A5. Right? Because A2 plus A5 would be A7. And what kind of b do I have to put in here to give me a b to the second power? Well, that's b to the first power, right? So I have to put a b to the first power here. Because b to the first power times b to the first power gives me b to the second. And that would give me that expression, that term right there. Let's pick another one. Let's pick this one. So 24, 64, 28, 64, 32, 110. What's the highest number I can pull out? Oh my god. Is it 8? I'm not too sure. You know what? We're going to do the ladder method. 28M, 64H, 32W, 110. I can pull out definitely I can put out a 2, so that's 14M, 32H, 16W, and 55. Is there any number that goes into these? No. So the biggest number would be a 2. So inside. So a 2 multiplied by what would give me 28M would be negative 14M. Right? Well, 2 multiplied by what would give me negative 64H would be negative 32H. 2 times what would give me 32W? Here's my answer, 16W plus 16W. And 2 times what would give me 110? Here we go, 55 plus 55. So this would be the factored version of this expression. Okay, and I'm not going to use, you shouldn't use a ladder method for this when you have variables in common. In this case, I had no variables that were shared, so the only thing that pulls out was a number, not a letter. Solve each 2 steps. I'm going to just pick, let's just pick this one. So draw a line, draw a line. So first thing is plus 12, plus 12. These 12 become 0. I bring the negative 4/5 a. Equals, and negative 32 plus 12, there's more negatives, so I'm going to get 20. Negative, by the way. Now I'm going to multiply both sides by the reciprocal of this. I'm going to multiply that by negative 5 over 4, and negative times negative 5 over 4 over here. This simplifies, right? And then a negative becomes a positive, or just 1. All these things become 1, 1, 1, 1. So I just get a. Over here, I can simplify for multiply. 4 divided by 4 is 1, and 20 divided by 4 is 5. So I get negative 5 times negative 5, which gives me positive 25. You can check, and let's check. It's negative 4/5. I'm going to replace the a with 25. Minus 12 equals 32. We want to make sure that the left side and the right side are equal to each other. 5 divided by 5 is 1. 25 divided by 5 is 5. Negative 4 times 5 is negative 20 now. Minus 12 equals 32. Negative 20 plus negative 12. That's, if you like to see it that way, you can change it to an addition problem. And the negative plus a negative is going to be more negatives. And then you're going to get negative 32 equals negative 32. And that equals, and since both sides are equal, I know my equation is true. And the value of a is also true. Okay. I think that's it. I'm not going to do too many because you don't need to. I mean, those should, well, let's do one of these. So I want to get rid of the constant, so I'm going to do plus 5. And I'm going to do plus 5 over here. These two become 0. I can drop down the negative 7y. On this side, 23 plus 5 is 28. I will divide both sides by negative 7. And if I cross these two out, they become 1, and y equals negative 4. If I substitute, I get 23 minus equals negative 7 times negative 4 minus 5. 23 equals, a negative times a negative is a positive. 7 times 4 is 28 minus 5. 23 equals 28 minus 5, which is 23. And you can say that both sides are equal. So that's pretty much should guide. So you can also use the video for the first review sheet. And this, just make sure you're specific in your explanation. Okay, I added 32 to both sides because addition is the inverse operation of subtraction, and then I multiply both sides by -8 because it's the opposite of division, because that's what's happening over here, right? And I divide it by multiply by -8 because I want a negative times a negative to become a positive, so I have a positive constant here. I want k to be positive and by itself. Okay, so remember all those steps. All right, that's that.